Going on to chapter 4, section 1, this deals with inequalities. And we did a little bit of this earlier, but solutions of inequalities we'll treat here in some detail. Interval notation that we did earlier in chapter 1 and chapter 2 we'll treat here. The addition principle for solving inequalities, the multiplication principle for solving inequalities. This will be a review of our equation topics a little bit. And then later we're going to do some word problems. So this is going to be sort of a long lesson. In chapter 4, we only do this one topic. So let's give you some background. Now, for inequalities, we had said there were 4 kinds of inequality signs. We said it was less than, greater than, less than or equal to, greater than or equal to. Now, when we plot these on a number line, and we'll be doing some plotting, how we write these inequalities on the number line is critical to interval notation. So we had said that when we are putting this on a number line, if something is less, we use a parenthesis that faces to the left at the number we're interested in. For this one, if we say it's only greater than, we're going to use a parenthesis facing to the right, again, at the number we're interested in. For this one, now instead of using a parenthesis, when it includes an equal sign, we use a bracket, again, facing toward the left. Then it's for here, a bracket facing toward the right. So what this means is that whatever number is there is not included in the set. Here, the number is included in the set. Now, to write this in interval notation, let's do a few examples here. So we're going to say x is less than 2. So there's our number line, and 2 is the number we're interested in. Now to graph this, we're going to say 2 is less, so we use this symbol, a parenthesis, that faces this way, and then we darken in that. Now, to put this in interval notation, this would be written, where is it coming from? Well, it's coming from negative infinity up to, but not including the 2. So when you have 2 parentheses, this is referred to as an open interval. Now, suppose we change that, using the same model, to also equal. Well, we then go from a parenthesis now to a bracket, and just change this to a bracket. And that is now half closed, because this one would be open, but this one is closed. So half open interval would be this. Now, if it were x is greater than, let's say, 2, it will be a graph in which at 2, we will have a parenthesis and a line indicating it's going on. That's your ellipsis, in a sense. So to write this in interval notation, we would say it starts, but doesn't include 2, and goes to positive infinity. And if we change it to equal to as well, we would change our parenthesis here to a bracket. And that would be interval notation for this. So making the graph of what you are illustrating is kind of crucial to getting a good handle on interval notation. So with that in mind, let's do the answering of this. Well, which letter, A, B, C, D, is our inequality? Well, D illustrates an inequality. Which is our open interval? Well, the one that has two parentheses. So that's C. Closed interval, something that has two brackets, that would be B. And then half opened is one with just one parenthesis, one bracket. Again, I don't usually do these, but as background to understand the connection between our terms here, open interval, closed interval, half open interval, and then tying it into our graphing and interval notation. Okay, going on to examples 5 and 6 now. They're simply to say if we replace the y value in our inequality with a certain number, does it make that expression, that inequality, true? And we just have to answer yes or no. So some of these we can do in our head. If you need to write them out, that's fine. But we'll do them in our head. So if y is 5, 2 times 5 is 10. 10 minus 1 is 9. Is that greater or equal to 7? Yes. All right, we put a 4 in there. 2 times 4 is 8. 8 minus 1 is 7. Is 7 greater or equal to 7? Yes. Now if we put a 0 there, 2 times 0 is 0, minus 1. Is minus 1 greater or equal to 7? No. And if you put a negative 2 there, that's going to be a negative 4, negative 5, that's no. Now, for number 6, it's a little tricky this way with that other y on there. So I'm going to solve this equation a little bit by transposing this y to this side. So now it becomes 4y plus 1 is less than 8. So I made it easier to work by just transposing the y, adding a y to both sides. So now I can do it pretty easily. Is 4 times negative 3, that's a negative 12, plus 1, a negative 11, is that less than 8? Yes. Now here, this is a positive 3. 12 plus 1 is 13. Is 13 less than 8? No. So that's not true. And then here we have 4 times 2 is 8 plus 1 is 9. Is 9 less than 8? No. And then we make 4 a 0. Y is 0. 4 times 0 is 0. Is 1 less than 8? Yes. Okay. There we have it, 1 through 6.